So today we're talking about section 4.1, which covers circles and equations of circles, and it starts on page 159. So the really important thing here when we're writing the equation of the circle, the standard form of the equation of a circle with center HK and radius R is this equation right here. So this equation actually comes from the distance formula. If you have your center point and a point on the circle, you find the distance, and that tells you the radius. So you use this then to find the equation of the radius and using the distance formula. So really you just need to learn this formula, but you can derive it from the distance formula. So if we want to write the equation of a circle with center at -3, 2 and radius of 4, we subtract the x-coordinate, so it's going to end up being x plus 3 squared plus y minus its y-coordinate 2 squared equals our radius squared, 4 squared, which becomes 16. So we have a circle here with its center at 1, -4. So we take our x minus the x-coordinate 1 squared plus y minus our y-coordinate. So we end up getting plus 4 squared equals our radius squared. Radius is 2. 2 squared becomes 4. So this one's a little different. We have our center and we know a point on the circle. So if we think about what it means to be a circle is all of the points the same distance away from a center point. So if we find the distance between our center and our point on the circle, it should tell us what our radius value is. So we use the distance formula. Distance is the square root of our x2, which is -2, minus x1, -2 squared, plus y2, -1, minus y1 squared. So this becomes 0. This becomes 6 squared, which is 36. So our distance is 6. And again, this is a representation of the radius because it's the distance from the center to any point. So knowing now our center value and our radius, we can write our equation. So we get x minus the x-coordinate -2, which becomes x plus 2 squared, plus y minus the y-coordinate 5 squared equals our radius squared. Our radius is 6. So our equation there would equal 36. So we can use this to help us find the equation of a circle, to graph it. So oftentimes you'll get an equation, a second degree equation in 2 variables like it talks about here. So in order to graph this equation or to get our even standard form, what you have to do is you have to complete the square on both x and y to put the equation in standard form, which we use to identify the circle's center and radius. So what we do here, we write our equation. You prepare to complete the square by pulling apart the x's and pulling apart the y's. So we take the x pieces, the x squared minus 10x. We take the y pieces, y squared plus 6y. And then, as usual, we move the constant over to the other side. So if we want to complete the square twice, based on our x values, our b is -10. So our b over 2 is -10 over 2. So when we square that, it becomes 25, which we add to both sides there. And for our y's, our b is 6. So our b over 2 is going to be 3. 3 squared is 9, which we then add 9 to both sides. So once we've completed the square twice, we'll end up with x minus 5 squared. We'll end up with y plus 3 squared. And that should equal 4. So that tells us that our center is at 5, -3. And our radius is the square root of 4, which is 2. So when you graph that, you'll graph your center at 5, -3. And then you take your look at your radius and go that many up, down, left, and right. So if our center is at 5, -3, radius is 2, so you move up 2, right 2, down 2, and left 2, and use those as your basis when you draw your circle. So let's try one out. We have to group our x terms, group our y terms, and move our constant to the other side. So we end up with x squared plus 4x. We know we're going to add something here when we complete the square. Plus grouping our y's, y squared plus 6y plus something else here when we complete our square. It's going to equal our -4. So when we complete the square on our x's, our b is 4. Sorry about that. Our b is 4. So we'll get our b over 2, 4 over 2, which is 2. 2 squared becomes 4. So that's what we add to both sides there. With our y's, our b is 6. So when we take our b over 2, that's 6 over 2, which is 3. 3 squared is 9. So that's what we add to both sides there. Our perfect square would become x plus 2 squared. Our perfect square here would become x plus 3 squared. And then we combine our terms on the right. Negative 4 plus 4 is 0. 0 plus 9 is 9, which means our center is going to be at negative 2, negative 3, and we'll have a radius of 3. So we can graph that. Center at negative 2, negative 3, radius of 3. So we'll put a point up 3, to the right 3, down 3, and to the left 3, and then do your best to draw a circle. Mine are obviously not very good. Now let's try another one. So there's 2 ways you can do this. If you notice, our coefficients are not 1. So you can either factor out a 1, or I just went ahead and divided everything by 1. Either way should get you to where you're trying to go. So I divided everything by, 9. Divide everything by 9. So that's what I did first. And I also moved that 209 to the other side. So dividing everything by 9, I ended up with x squared plus y squared minus 6x minus 8y equals negative 209 over 9. Unfortunately, that one's a little unfriendly. So now we group our terms. So we'll get x squared minus xx plus, we know we're going to add something, plus y squared minus 8y plus, we know we're going to add something there, equals that negative 209 over 9. So when we complete our square, our first b term is going to be negative 6 over 2, which becomes negative 3. 3 squared is 9. Our second b term is your negative 8, which we divide by 2, becomes negative 4. Negative 4 squared is 16. So to both sides, we will add 9. We will add 16. So our perfect square is going to be x minus 3 squared plus y minus 4 squared equals, you can plug this into your calculator, you end up with 16 over 9. So this means our center is at 3, 4. Our radius, we take the square root of our right-hand side here, which becomes 4 over 3. So when we graph this, we're going to be at 3, 4. 4/3 is a little bit bigger than 1, so it'll be about here, about here, about here, and then about here. And there's our attempt at a circle. So we can also use these to solve real-world problems. So a circle in a coordinate plane divides the plane into 2 regions, the points inside the circle and the points outside the circle. So points inside the circle satisfy the equation where we are now less than our radius because our distances are less than our radius value, versus if we're looking at the points outside the circle, we'll want our distance values to be greater than the radius. So you have to be paying attention as you work through these problems about whether these locations are going to be inside or outside of your circle. So the first situation here is going to be within the 3-mile radius. So that means they're going to be looking inside the circle. You can see that there, they've worked it out. So then for this one, we're using the same picture as before, but in order for a student to ride the bus to school, the student must live more than 2 miles from the school. So this time we're going to be looking outside of our circle. So which of the 5 friends are eligible to ride? So we look for where's the school. Well, the school is going to be at 1, negative 2, and that's where we're going to start here as we can finish up this problem next time.